So let's go to case number 2 now. Case number 2. Now case number 2 is where there's a collision, but it's slightly different. There's a collision, right? So with this collision we say they are separate before right, together after. So what do we mean by this? We mean that there's a coupling, they hook up, they couple with one another. There's a coupling of the objects. So let's get our objects going. Let's do them over here. That's object A, and let's say this is object B, and object B is just standing there, and then again that is before. That is before. Now let's look at what happens after. It knocks into object B, A knocks into object B, and they move off together. Okay, and that's my velocity vector. This is V initial, this will be V final. This is after. Right, so we need to come up with a formula again, and we will use the principle of conservation of linear momentum, which says that P before, again this is of the system, is equal to P after. Okay, so let's see, what does P before look like? P before looks like this. It says, okay, before we've got the initial velocity, we've got mv, and we've got another mv, but afterwards we've got one mass, right, which is ma plus mb, and we've got one velocity that this thing relates to, which we will say v final. Okay, now you fill in a, b, b, and this is initial and initial. Again, work with the system, follow the way we do it, add up the momenta, and here there's only one object. The two masses come together, they form one object with one velocity and one total mass where the A and B masses are added together. Okay, so there's P before equals P after, and this is what we get. So this is the formula that we will find when we have case number 2. Now remember how the cases work. Case number 1, separate before, separate after. Case number 2, they join, they move off together.